In the last lecture, we talked about LANs, which are the networks closest to us, like the network in a home, school, or office. Now, we're zooming out. In this lesson, we're talking about WANs, or wide area networks. A WAN is what helps networks stretch across much larger distances. Instead of just connecting devices in one building, a WAN helps connect places that are far apart, like different offices in different cities, different regions, or even the larger networks that make up the internet. WAN stands for Wide Area Network. The key word here is wide. A WAN is built to connect across a much larger area than a LAN. So while a LAN is local, a WAN is designed for distance. That distance might be across a city, across a state, across a country, or even across oceans. So if a LAN is your nearby network, a WAN is the type of network that helps link far apart locations together. A really simple way to think about it is this: a LAN helps people and devices communicate in one local place. A WAN helps separate local places communicate with each other. For example, imagine a business with one office in Tampa, another in Atlanta, and another in Dallas. Each office may have its own local network inside the building. But if those offices need to stay connected, they need something bigger than a LAN. That is where a WAN comes in. WANs are a major part of how large organizations stay connected, and they are also a major part of how the global internet exists in the first place. When people say the internet, beginners often picture it like one giant cloud that just exists somehow. But underneath that cloud are real long distance network connections. Wide area networks are crucial for building everything from large corporate networks to the global internet. So the internet is not magic. It depends on long distance infrastructure that connects one place to another, then another, then another, until traffic can move across massive geographic areas. One of the most eye opening parts of networking is realizing that data often travels over very real physical paths. WAN cables may be buried underground, attached to utility poles, or laid under the sea. Yes, under the sea. There are large numbers of submarine cables lying on or under the ocean floor, and some of them cross major oceans. So when we talk about a WAN, we are not just talking about an idea. We are talking about real infrastructure built across land, coastlines, and oceans so data can move over long distances. WANs are impressive, but they are also hard to build. There are two major challenges: right of way and the physical challenge of laying and managing long distance cable. Right of way basically means getting legal permission to place cable across land or property. Then there is the physical side. Sometimes cables must cross rough land, rocky terrain, cities, pole routes, or underwater environments. So, one big reason WANs matter is because they take a lot of planning, engineering, money, and maintenance to build and keep running. Now, let's talk about an important WAN idea called the last mile. The last mile is the part of the network that connects end users, meaning homes and businesses, to the larger internet. In other words, it is the final stretch between the provider's larger network and the actual customer location. Access networks connect end users to the global internet, and that this last mile is often one of the hardest parts for providers to support. Why? Because running infrastructure out to lots of individual homes and businesses can be expensive, while the money coming in from each customer may be relatively small. Here are several examples of last mile technologies. These include fixed wireless access or FWA, GPON, which is a fiber based access method, DOCSIS, which is tied to cable internet systems, and MAN related metro fiber designs inside metropolitan areas. At this stage, you do not need to master every technology deeply. What matters most right now is understanding that the last mile can be delivered in different ways depending on the provider, the environment, and the population density of the area. You are also expected to recognize MAN, which stands for Metropolitan Area Network. A MAN is not the same thing as a full WAN, but it lives in that larger distance world. A MAN is usually focused on a metropolitan area, meaning a city or urban region. Metropolitan area networks are commonly built as ring based networks within a network area, and they may connect outward to smaller hub and spoke networks or other local areas like campuses. So, a simple way to think about it is this: a LAN is local, a MAN is city scale, a WAN is broader and can connect across much larger distances. Now, let's talk about transit providers. Transit providers help build the larger core of the internet by connecting last mile providers, cloud providers, and other large scale networks. So while one provider may focus on getting service to your neighborhood, another provider may be helping connect major networks across much bigger regions. Transit providers may operate facilities such as a point of presence or POP, a co-location facility, and peering points. You do not need to get lost in all of these terms yet. The big idea is simple. Some providers focus on getting connectivity to the customer, and some focus on connecting large networks together so traffic can move across the broader internet. Let's go over two major WAN topologies: ring and hub and spoke. A ring topology gives devices at least two paths through the network, which helps with resilience if one link or one router fails. A hub and spoke topology is useful for connecting many end locations efficiently, especially when lots of locations need to reach a central point. But each one has trade offs. Ring topologies can face growing delay and traffic competition as more nodes are added. Hub and spoke designs are efficient, but if they are single homed, a single link or device failure can interrupt service. So, just like with other parts of networking, WAN design is always about balancing reach, cost, performance, and reliability. So, let's wrap this up. A WAN, or wide area network, is a network built to connect across large geographic distances. WANs help connect cities, regions, large organizations, providers, and the larger networks that form the internet. They rely on real infrastructure, including long distance fiber, pole routes, and undersea cables. They also include important ideas like the last mile, MANs, transit providers, and long distance typologies like ring and hub and spoke. So if a LAN is the network closest to us, a WAN is the bigger network world that connects those local places together. And that is how networks scale from a building to a city to a region and all the way out to the internet.